final speaker for the day is Keith Mattix. Keith is an engineering lead at Microsoft Azure, working on open source technology such as Kubernetes. He is a Tennessee native from Germantown, Tennessee, but now lives in Birmingham, Alabama with his wife. And Keith, come on up here. All right. And highly recommended from the DevOps community, actually, too. So,
all right. Hello, DevOps Days, Chattanooga. How y'all doing? Glad to hear the energy at the end of the day. Like I said, my name is Keith Mattix. I'm your closing speaker for today. And I've loved getting a chance to listen to the talks, sit in the open spaces. Conferences are such an amazing part of what I get to do. And why don't you join me in giving a big thank you to the organizers for putting this together. The title of my talk is To Mesh or Not to Mesh, Lessons in Technical Decision Making. So to start off, I want to ask a question to all of you. Raise your hand if you've heard of a service mesh before. More than I thought. Do any of you put your hand back up if you actually use a service mesh? Wow, got 2. Awesome. Maybe 3, 4. Okay, wow, that's awesome to see. So a little bit about me before we get too deep into things. Like I said, I'm from the Memphis, Tennessee area, but now I live in Birmingham, Alabama. I work at Microsoft Azure doing open technologies like Kubernetes and things like that. I do a lot of open source work in certain different capacities. If Gateway API, Ingress, Gamma, if any of those things sound familiar to you, reach out to me. Or if you're just curious, then reach out to me as well. Happy to talk to you about it. So most talks like this typically have the speaker get up and they give you this long list about what is a service mesh and give you this list of features. I'm not going to do that today. I want to talk about you first. My goal for this talk is simple. I want to help you understand to come to the answer of a simple question. Is your organization ready for a service mesh? That answer could be yes. That answer could be no. But by kind of starting from first principles, what I hope that we'll actually take away from this is not only the answer to that question, to mesh or not to mesh, but also some generally applicable lessons about technical decision making that you can apply anywhere, even outside of the service mesh realm. Everybody ready? Ready to do this? All right. So the first thing I want to do is talk to you about cloud native architecture for microservices. And if you are deploying microservices in a cloud native way, then this diagram probably looks pretty familiar to you. The first thing I want to draw your attention to is this gateway layer here on the side. And when I say gateway layer, I truly mean a layer. I'm not trying to be specific to any kind of technology, not referring to a specific number of instances. This could be if you're on Kubernetes, a full-fledged Kubernetes ingress controller like Contour. It could be a typical traditional standalone proxy like Nginx or HA proxy, Kong, Apogee, anything like that. And I recognize that the term gateway is a bit overloaded nowadays, right? Gateway can mean anything. There are a bunch of startups and products that will sell you on a gateway. And so I'm going to strip the definition back a bit. For the purposes of this conversation, right, we're having a conversation. For the purposes of this conversation, a gateway is going to be any series of network hops that adds context to your request. Keith, what context? What are you talking about? When I say adding context to requests, what I'm talking about is the gateway layer translating an opaque request that you have no idea what this means. Your system doesn't recognize what kind of request this is. And the gateway layer starts adding information, metadata, and things of that nature to help your system make sense of what's actually going on. A good example of this comes in the authentication and authorization realm, right? A request comes into your gateway layer, and your gateway will look at it and say, okay, who does this represent, right? Is this a user? Is this a anonymous user? Is this somebody who signed in? That's the authentication piece, right? Then the authorization piece, once you know who this user is, now you have to figure out what is this user allowed to do. And so that's the auth-in, auth-z, the authentication, authorization side of the gateway. And that's generally what I'm talking about when I'm saying adding context. Another good example is telemetry, right? How many times, raise your hand if you've had to comb through gateway like Nginx access logs before, trying to figure out what request, raise your hand, anybody dealing with access logs here? Right, especially when you've got a bunch of different logs, that's difficult to comb through. One of the great things that most gateways will do is that they'll add a request ID header so you can scan through and trace your requests through your entire architecture. It's not too bad to comb through a bunch of logs if you've only got 2 hops between services. If you've got 20, that's slightly less fun. So, gateways can do all sorts of things. They terminate TLS. You may know this as SSL encryption, things of that nature. They keep the communication between your client and your server encrypted and safe. And so there, like I said, all sorts of things that gateways can do. So once your network traffic gets past the gateway layer, and we're going to assume that you've gotten through security groups, through your firewall rules, network access control lists, all those kind of cloud level security mechanisms, but you've gotten past that. Now we're going to get into the actual compute over here on the right side of the diagram. And just full disclosure, I'm going to be probably speaking in Kubernetes terms here because that's what I'm familiar with. But this could easily be a fleet of VMs, a fleet of EC2 instances if you're on AWS. This could be a set of serverless instances. Regardless, it doesn't really matter. It's just, you can think of it as generic compute, and the problems will still apply. So you get from your gateway layer into your compute, and with that step, I want you to start putting yourself in the shoes of a typical application developer. And if you're in the shoes of a typical application developer, then most of what I just said is absolutely boilerplate, right? It has to happen. Somebody's got to terminate TLS, but I don't want to care about that if I'm writing features. My job is to write the customer-facing functionality that makes my company money at the end of the day, right? If one of these things breaks, if I see a network error or a connection refused, I'm calling ops straight away, right? And many of you have lived that reality. I know I have. And with containerization, that actually has gotten a lot easier for the application engineer to just focus on writing features, to just focus on getting money in the company's pocket. Now, the promise of containers is that you can have a very lightweight deployment artifact. Instead of shipping a huge machine instance, you just take your business logic written in your language of choice. You ship a couple of OS level packages, maybe something like curl or OpenSSL or ImageMagick or whatever, and you've got a file system. You put that together and you ship it off to your Kubernetes cluster or your cloud provider's container orchestration tool. Whatever can speak containers, you ship it there and it runs in prod, and it's a glorious reality, right? And so this is really attractive to a lot of people, and containerization for the past decade or so has taken the world by storm. Now, when you look at this logical picture that I've drawn up here of what a container is, you might pick up on something here. You might say, Keith, this sounds cool and all, but this doesn't feel complete. If I'm just shipping business logic and the OS to my system, how do I observe it? How do I find out what breaks? How do I get my traces, my metrics, my logs? Where is all of that in this diagram? Now, I turn to you and I say, you're absolutely right. Yeah, telemetry in 2022 in a modern production-ready application, you've got to be able to observe your software. You've got to be able to see what's going on in your container. And this can take a little bit of work to do in your system, right? Your application has to maybe authenticate to a logging endpoint, or they've got to instrument traces when each network request comes in. But we've got some smart engineers. We can handle it, right? We can add in the telemetry part of this. But wait, we're in Kubernetes, or we're in our ECS cluster, or Azure Container Apps, or whatever compute platform we happen to be using. The network traffic, by default, is not encrypted. And a while ago, that might not be that big of a deal, but we're seeing nowadays in 2022 that unencrypted traffic is a big, big risk for organizations, right? If somebody gets host-level access to one of your nodes, then they can run a TCP dump and you're sunk. All of that traffic that's been going between your microservices that may contain social security numbers, credit card numbers, PII of all sorts is now laid bare before your attacker. And if you happen to be in a highly regulated industry and you're subject to things like FedRAMP or HIPAA or PCI compliance, then this is your doomsday scenario. So many organizations are finding that you can't avoid encryption, service-to-service encryption. And unlike telemetry, this is a bit more complicated, right? Setting up an internal trust store, distributing that trust store, creating processes for revoking certificates, all of that is now bundled not only with your security organization, but now it's right in the face of your engineers as they're deploying their applications to production. It can be a pretty tall order, and onboarding new engineers onto the code base becomes difficult. Now, you can imagine, I'm looking out in the audience, I see some of you aren't having to imagine, you're living this right now. By the time you've invested in building out a production-ready PKI infrastructure, now this lightweight deployment artifact isn't looking so lightweight anymore. Now you're having to really get into the nitty-gritty each and every time your application developer who just wants to write features for your business, you've got to deal with all of this. And by the time we add network resiliency to things like retries and timeouts and circuit breaking, the lightweight deployment artifact we had before has now cracked and broken under the weight of all of these concerns. Wasn't the promise of containers that we could just ship our business logic, ship our application, and nothing else, and not have to deal with all of this new complexity? This is a lot for the average service owner to manage. This sounds a lot like broken promises, like the promise that we were all sold about containers was broken, and I confess, a bit of this is unavoidable. The fact is, no single architectural decision that we make is free of trade-offs. And in the whole monolith to microservice debate, I feel like a lot of people missed that point, right? We hopped over to microservices because it's going to make us more agile. It's going to help break down all of the silos and help us to iterate quicker. But what we've done with microservices in many cases is instead of having a single runtime, a single binary where everything happens, we're now distributing these services across a network. And anytime you do that, anytime you add a network in the middle, you add risk. You add instability. Now, my first framework I used in production was Ruby on Rails. And I remember that my account model needs to reach out to my user model, which all gets called whenever I do a cart checkout. And when something breaks, I can get a stack trace, instrument it with New Relic or something like that. When you move from that model into microservices, now that account model is not an account model, it's an account service. That's deployed separately from the user service. That's deployed separately from the checkout, from the cart service where you do your checkouts. And we've added this instability that is called networking in the middle of some of these critical operations. The thing is, we as human beings, we don't read zeros and ones on the wire. So when we put a network in between our dependent services, it gets harder for us to understand what's going on. Yeah, it will be nice to be able to have every single TCP packet logged somewhere for me to inspect, but if you want to pay those storage costs for your log provider, good luck, because that will add up very quickly. You leave yourself open to things like I talked about earlier with packet sniffing if somebody gets host access. And then the typical transient failures that occur with networking. And look, I'm not trying to disparage your cloud provider's network. I work for a cloud provider, right? There's some amazing strides being done in network engineering. However, most of the work being done there is around resiliency. And there is no such thing as a fully up 100% of the time network. There's just simply not. The microservice move does a lot of great things for us, but we have to face the fact that it introduces risk into our systems, and this risk has to be managed. And the way you typically manage this risk is what we've talked about already. Through telemetry, traces, metrics, logs, manage it through encryption, and by adding retries and timeouts. And we know this is complex stuff that you've got to deal with. And there are a couple of different strategies that organizations use in order to make this happen. One option you could do is to use a language like Java or the .NET framework that have been around for so long and have a proven production story. I looked it up the other day. Java turned 27 this year, and I'm 24. Java has been in production longer than I have been alive. There are some fantastic, it's got a tried and true story in prod. Or you know what? Maybe you're working for a startup and you've got to prioritize productivity and velocity better than anything else. And you use JavaScript because, oh, I can use it on my front end, my back end. If I use Mongo, it can be in my database. And that's an attractive thing to you. Or maybe you've got a bunch of Ruby experts because that's what the market has right now and as you're hiring. And so to prioritize your developer happiness and the speed and effectiveness, you choose to use Ruby. What organizations in those cases end up doing, typically, is they get some senior plus engineers in a room and they write this package that provides a lot of abstractions and wrappers for common operations like network requests, and you can configure your circuit breakers. Or maybe you have a database wrapper for issuing database calls, right? Raise your hand if you've used one of these two approaches in your organization, right? Either using Java or a utils library, utils package. Okay, I see a couple of hands out there. I need to talk to y'all, figure out what you're doing. But, these two options work perfectly well in a lot of organizations. There are some amazing success stories out there with people using these two options. But they all, again, come with their own trade-offs. If you're using something like Java, it can be very difficult to dig through those stat traces when something goes wrong and to figure out what the active configuration is at runtime in the middle of an incident. Wait, there's this override in this file, but then if I go in this XML file, I've got to go here. It can be difficult when you're in the middle of a big incident and downtime. If you're running your own utils library, and some companies can do this, that they've got a great internal open source culture. But when a CVE comes through, like there was an OpenSSL 3 CVE coming out the last couple of weeks, now somebody's got to go up and patch that utils library and then knock on the door of each one of your consuming teams to go and update their package dependency. Right? There is a trade-off with either one of these approaches. And what I'd like to actually, propose to you is one of the reasons that we often find these approaches to be so awkward is because these actually aren't application-level concerns. These things like encryption and retries and timeouts, I would say these are concerns of the network, right? Things that your application developer who's writing features for your company doesn't need to have to deal with. Wouldn't it be better if we could just manage this at the network level instead? So I want you to go back and think about that first diagram that I put up on the screen with your gateway layer and your compute. That gateway layer did a lot of the things that we've been talking about. It's got a place where you can add retries and timeouts. It's got a place for you to be able to encrypt at least part of your traffic. And it's got places for you to do telemetry and add request IDs and things like that. We've already talked about some of that. There's a strategy, there's a network, a deployment topology called hairpinning that essentially, instead of having your service-to-service communication be direct, what we're going to do is we're going to go through our gateway each time. Let's take a look at what that looks like. In this diagram here, let's say service A wants to talk to service B. Instead of going through your deployment network fabric, maybe in Kubernetes or your cloud provider or what have you, instead of doing that, what we're going to do instead is have our service go through the gateway each time. And so it's going to go up out of my cluster, outside of my compute, into the gateway, and then back into the compute to the end service. And what we've done here is now instead of having your application developer have all this stuff in their application, your ops team or your SRE team can program the gateway and set policy for retries and timeouts and default circuit breaking patterns and things of that nature. And as an application developer, hopefully you've still got their shoes on right now, this sounds great. If something goes wrong, I just call up ops because those folks have all the time in the world to fix my specific problem, right? Now I want to take a pause. We've run through about 3, 4, 5 different approaches to hardening your applications and getting them production ready in 2022. And I don't want to disparage any of the approaches we've talked about. These are all things that have worked. These are things that I've seen work personally. And they very well may work for you. And you may be using them right now. I don't want to disparage any of that. In fact, one of the things I'd like to point out is that this is lesson 1 of technical decision making. You've got to pick the trade-offs that work best for your organization. Can't tell you how many times I've seen people trying to chase the next big thing. Every new Hacker News #1, now we're going to put that into our stack. And that's a recipe for disaster for just about every organization, right? Everybody in this room knows their organization better than anybody else outside your organization. Use that knowledge to make the decisions that make the most sense for you. So after that little preachy detour, I'm going to get back into the tech a bit. There are a variety of reasons why hairpinning might not work, and I've listed a couple of them up here. Maybe going out of your cluster, outside of your compute, into your gateway could cross a cloud provider's zone boundary, and now you got to pay the egress cost of leaving the zone. Maybe you add latency from going out of your cluster and back inside again. Maybe, if your gateway is your cloud provider's load balancer, now you've got to deal with that load balancer being a single point of failure for all your application service communication. And I've been in incidents where that load balancer went down. It was not pretty. On the other side, when service B is receiving the request, now you've got to figure out, okay, where did this request come from? Everything comes from this gateway to begin with, so this looks like it's coming from the world. I don't know if it came from a service or a random user on the internet. Maybe decrypting mTLS can take a while. A variety of reasons why this could just be not fun for you. And so now I've got to figure out a better solution, right? We've established that these are concerns that are probably better addressed outside of the application, outside of your feature engineer's application deployable. And we've tried to go through the gateway, and that worked. Hairpinning is pretty nice, but now I've got this single point of failure that we lose context from, and we've got this dependency. And so what if, instead of deduplicating the logic from the application, we reduplicate it, but not in the application? What if we reduplicate the proxy? Congratulations, we've just invented the modern service mesh. I recognize that the term service mesh it might not be familiar to many of you, but at its core, this is all that it's doing. Not every service mesh has a sidecar right next to the compute that's receiving all the traffic, but many service meshes do. And so just to reiterate, what we did here is instead of sending all the traffic through our gateway, we put a small proxy next to each one of our compute layers. And when we did that, now we're able to continue to keep the context, reduce the single point of failure, and we're able to continue to, is my laptop dying? Yeah. All right. Appreciate everybody helping me out, keeping my laptop on. Give the term, keep the lights on, a whole new meaning. Anyway, the idea of service mesh and sidecars is that we are successful. Awesome. The idea of service meshes and sidecars is that by duplicating our proxy, we're able to keep our context, we're able to remove a single point of failure by not going through our gateway each time, and you're able to keep a lot of the same features that we talked about with hairpinning. We still get to keep retries and timeouts in the proxy layer. We're still able to add telemetry and get traces, metrics, and logs. And we get to gain a whole new level of features that we didn't have previously. We'll talk about some of those in a minute. So now I want to kind of bring the architecture discussion to a close a bit. And I want to talk about, what was the purpose of all this? Why did I spend 24, 23 minutes talking about architecture that you might already be familiar with? Well, I hope that by going through this process and starting from a base level architecture and talking about problem spaces, we've learned the importance of framing. This is lesson 2 of technical decision making that I want to impart to you during my talk here. You got to frame the problem appropriately. See, service mesh, as I hope I've just shown, is not an altogether new idea. It's just taking the proxies that we're familiar with already, like Nginx. There's a new one called Envoy, but we're just taking proxies, shrinking them down, and putting them next to applications. The main innovation here is around distributing the proxies themselves instead of having a single point of failure. It's just networking. It's just L4, L7, the things that you're used to. Just in a bit of a different arrangement. I want you all to see that service mesh is not an altogether new thing. It's not a silver bullet to solve all your problems. It's an evolution of your organization's network architecture. So instead of jumping straight into saying, hey, here's what mesh can do, let me sell you on what a service mesh does, I want you to think about the common problems and problem spaces that you're dealing with each and every day. proper framing is absolutely critical for sound decision making. I bet everybody in here can think about a time where the problem wasn't framed correctly and it led to bad outcomes, right? It's really easy to jump straight from a sales pitch and go into this cool new thing everybody's talking about. But in your organizations, when you're considering this question or any other question, make sure you're framing the conversation correctly to get the best outcomes. So with all of that being said, with all of that intro, let's finally answer the question, what is a service mesh? As I mentioned, at its core, a service mesh is nothing more than a distributed networking plane for traffic management and policy. So yes, if this sounds familiar to you, you may already be using a mesh in your organization. Many people write their own mesh-like solutions in their business, and they realize now, hey, this sounds like that Istio thing people are already talking about. The number of best practices that you need in order to deploy a production-ready application is continuing to rise higher and higher, right? I remember when I was getting started, it was this 12-factor app, right? And as long as I've got my environment variables with my application config, I'm good to go, as well as the other things. But now, man, you've got to have retries, timeouts, encryption, telemetry. And we had a talk about S-bombs earlier. Now, supply chain security is all the rage, and the number of requirements keeps growing and growing and growing. And not going to lie, it's intimidating to keep up. And that's why we're here, right? We're here to learn about what the industry is doing and to keep up with the ever-growing list of requirements for deploying the best software for our users and for our companies. And especially with the rise of things like Kubernetes and distributed deployment architectures, more and more small, medium-sized businesses, their deployments in production look like a big tech companies. But the problem is, that sounds good at first. They're resilient, can scale, et cetera, et cetera. But the problem with that is that you might not have the resources of a big tech company. You might not have the expertise or the skill or the general experience of running these scenarios. And what people are figuring out is that they still have to deal with all the big tech problems that come from a distributed computing environment, even without those big tech resources. And to be quite frank, that's why a lot of times you're seeing monoliths make a comeback, because people are tired of dealing with the distributed systems questions. But for those organizations where a distributed scenario is absolutely critical, and you've seen a lot of gain from that approach, I would say that a service mesh helps you actually get to 80% of big tech's network practices without being a big tech company, right? Because you've got a distributed proxy, that proxy can hold that functionality for you, and that stays outside of your application. I want to point out that a service mesh is not a single proxy or data plane implementation. There are lots of meshes on the market, and it's growing, every so often. You might hear about Istio, Linkerd, Console, Open Service Mesh, Kuma. Those are all different service mesh implementations, and they all do this same thing. So now what I want to do is I want to dig into a couple of spotlights on different features a service mesh might have. One of the big themes of service mesh is you get traffic management and traffic control. How many times have you wanted to make a change to your application and add a new version, but you want to make sure there's zero downtime between your deployments? And so that's where Canary deploys, A/B deployments, and typical progressive delivery has really taken off. A service mesh will allow you to do that at a fine-grained level with fine percentage tuning, like 3% of traffic to this version and 100% of traffic to this version. And by the way, let me look at my metrics for this application. Let me point you to some metrics to look at. And if the metrics start going down or up, then stop the rollout, right? Service mesh will give you some of that functionality. You can start mirroring traffic, so like a fire and forget kind of semantic where every request that this application gets sent somewhere else. This is useful for training AI models and machine learning models in production because you're mirroring traffic there. And one of the cool things is that a service mesh can use the context available to you to make intelligent routing decisions. One example of this in the Kubernetes world is that in Kubernetes, each node where your pod runs has and most cloud providers, has a label, has some metadata associated with it that tells you, hey, what region are we in within my cloud provider? What zone are we in? If your cloud provider supports it, what subzone or even rack are we on? And a service mesh can utilize that in order to make context-aware decisions. So keeping traffic within the same zone to reduce cost and latency. Or in the event of downtime, automatically failing over to the closest zone, things of that nature. A service mesh will give you a lot more power over your traffic management. Next, we've got observability. Now, we talked about traces, metrics, and logs and how important those things are. But a service mesh, instead of having that stuff live in your application, you can set up your mesh to do that easily, completely transparently without your application engineers having to know. There's support for fluent bit or standard out, things of that nature. And open telemetry, with the rise of open telemetry that some people are seeing, there's even more support coming in the future. The cool thing about mesh is that you get this really cool dependency graph. Because each service has a proxy, you're able to see exactly who talks to my service. That was a big question. I was working as a DevOps engineer a couple years ago, and during my entire stint at that company, we were striving to get to a point where every single service knew their dependency. And for context, we had about 200 to 300 microservices running in production. When you're at that scale, that's a hard question to answer. A mesh can give you that runtime level granularity to see what that dependency tree looks like. If any of you folks are security people, then this last one might be interesting to you, egress monitoring. Because you've got a proxy through which all your traffic is going through, you're able to say, hey, is this a known bad domain? Let's block that traffic. Or even better, if you're trying to work towards a zero trust security posture, well, I'm getting ahead of myself. Let's just move into security. Whoops. So because, you've got traffic going through this sidecar proxy, you can deny traffic to certain web pages and move to a zero trust approach where your service can't talk to any other external service except for the ones that you allow list, right? You can start locking down your system and not trusting any external domain. Because most security vulnerabilities, or security attackers rather, what they'll do is they'll get access to private information and then exfiltrate that somewhere. With a mesh, you can stop that by cutting out any egress that you don't explicitly allow. The big thing that a mesh allows in a lot of cases is automatic mTLS with certificates deployed and managed by your mesh itself. So you don't have to deal with the dance of making sure the certificate gets to your instance. The mesh will take care of that for you. And with a lot of the new NIST guidelines coming out about using short-lived certificates that expire every 24 hours, a mesh will give that to you right out of the box. I mentioned isolation between services, where only certain services can talk to one another. But you can also use a mesh for authentication, using JWT claims and only allowing certain issuers and things of that nature. So that was a lot. That was a big feature dump of mesh things. If those sound intriguing to you, come chat with me. I can tell you even more about how this stuff works. But I want to take a hard pivot into organizations right quick. And I bet you're probably wondering, why in the world are you talking about organizations at a DevOps Days talk? I want to first reference Conway's Law. How many of you have heard of Conway's Law in the past? Yeah, good number of you. It's a great thing to keep in mind as we are doing DevOps, whose entire premise at the beginning was about making organizational change. Conway's Law is absolutely a relevant thing to keep in mind. And it's best stated like this, which is directly from the founder. Organizations which design systems are constrained to produce designs which are copies of the communication structures of those organizations. This was coined about 55 years ago by Melvin Conway, and this is lesson 3 that I want to teach you about technical decision making. Our organizations need to complement and not conflict with our systems. Another way of formulating Conway's Law is that if you've got a system being worked on, a compiler being worked on by 2 different teams in 2 different locations, instead of a 1-pass compiler, you get a 2-pass compiler, right? There's a direct effect on how you build software. And meshes and all software in general are the exact same way. They're products and projects designed to be used by groups of people. there's ways that we can take Conway's Law into account and build organizations or build software to anticipate the organizational change. One example of this, and this is, if you want to do some Googling later, this is called the inverse Conway's Law. If you know that you're working with teams that are in 6 main different locations across the globe, okay, well, this software that we're building is going to have 6 major subsystems. You want to anticipate the change and build and design your software around it. There are some pros and cons to that, but that's one way you can take Conway's Law into account. So I want to talk a little bit about, with Conway's Law in mind, and we know that our organization has an impact on our software, I want to talk about optimizing our organizations for mesh, or any technical thing that you're thinking about adopting. One thing that I've said that's a bit controversial is I think it's important for us to emphasize and favor transformational adoption over transparent adoption. So many times in our organizations as DevOps or SRE, we want to make our changes or implementation details transparent to our users, and that is fine, that is fantastic. I'm completely on board with that. I think that creates a great developer experience. But for major changes, like a mesh, it's basically an overlay network, right? When you're making major changes to your system, sometimes we can try to move too quickly. We can try to be too transparent. In our team, like our DevOps and SRE team, who are on the front lines making these changes, they're moving forward and we've left the rest of our org behind. And they're hopefully trying to catch up, and they want to go back to the old way, right? If we try to favor transformational adoption, and we work with those teams and empower them to understand the new environment that they're working in, the new reality of their software, then we can have some better outcomes. A good test for this, if you're doing this well, and it kind of leads into my second point here, is look at your on-call escalation policies, right? When your back-end software has a 500 error, who's the first person on that escalation list? If the first person you page is DevOps or SRE, you might be limiting the potential for growth of your back-end engineering teams. Let them truly learn to own their services. Because at the end of the day, distributed systems imply distributed responsibility. If your network proxy is distributed, there is some cost of ownership of having that distributed. It unlocks some amazing potential and amazing feature sets, but now it's right in the path of your application developer, and not as much as it was before when it was in the container, but why shouldn't feature engineers know about the network, at least somewhat? Are product engineers truly being given the tools and training to own their services holistically? And then finally, these kinds of major changes are difficult, and they almost never go right the first time. With that in mind, start proactively thinking about failure as an opportunity and not as something to be blaming people for. Blameless culture is extremely important to being able to iterate and to grow. And if we do that, then we have opportunities to have everybody learn. So, I say all that, to mesh or not to mesh? That is indeed the question. And I can't answer that for you. If you want to answer this question in your own organization, or if you need to answer a similar question for, it's not service mesh, maybe it's Kubernetes, or maybe it's this new product that you're looking to change that's going to revolutionize the way you do things, listen. That's the first step. Listen to your customers. What kind of features do they need, and does a mesh or X other product help you get there faster? Listen to your backend engineers. For DevOps and SREs, those are your customers. Listen to what they need in order to get things out the door to their users quicker. Remember, this isn't a binary answer that is, forever and done. You don't say yes and then it's yes forever, or no and it's no forever. Beware of sunk cost, the sunk cost fallacy. If the answer is no, when and how are you going to reevaluate? What are going to be the signals for you to reevaluate that decision and to roll back if needed? And if yes, really emphasize the how. Make sure that you are anticipating failures and giving yourselves timelines that are going to actually be realistic. So, I know I probably caused you to have a lot more questions than answers, and that's kind of on purpose. I invite you to, we've got, I think, have about 5 minutes here, perhaps, to ask questions, or if we don't have time, come chat with me afterward. I'd love to talk about this stuff with you. I'm at Keith Mattix on Twitter and GitHub. And for no reason at all, I also have my, my Mastodon instance on there. And you can find me on the CNCF and Kubernetes Slack and chat with me about just about anything. Thank you for your attention. I really appreciate it. Good. All right. Any questions? Got one right here.
So I know that in the end, the answer is it all depends. But when you've got your mesh setup, when you've got that sidecar, whatever you're using as your distributed proxy, how do you avoid overloading it? And at what point do you say no more?
That's a great question. So you're absolutely right. It does depend. There are different strategies that you can use. One thing I would be keeping in mind is the power of horizontal scaling. In general, resources like memory and RAM are pretty cheap. And so if an individual sidecar proxy is being overwhelmed, then maybe add more instances and distribute that load in a more efficient way. If that's not working, then figure out why there's a bottleneck on one particular proxy or the other. Maybe that application is receiving too many requests. Maybe it could be broken up into a couple of different services. Maybe you need to, this is extreme, but perhaps your system is better served as a monolith. Those are all questions you can be considering. Any other questions?
The service meshes, I think you explained really well the benefits, so thank you. I'm wondering though about like companies that are using like many different compute platforms, like if they're running on EC2 instances and ECS and serverless, are there any service mesh implementations to address those kinds of configurations?
Yeah, that's a great question. So in general, service meshes are very Kubernetes focused. But a couple of the big ones like Istio and Consul especially, has the capability to run as a process on just about any compute environment. And all you really need to do to be a part of the mesh is have a connection to the mesh control plane and be able to intercept traffic. And maybe that's IP tables, maybe that is, if you're on Linux, maybe that's some other mechanism for forwarding. But as long as you can do those things, you can pretty much have a mesh up and running. Many people have, before a mesh was a thing, the Envoy proxy was used internally at Lyft as a mesh for many years across their very heterogeneous compute environment. So there's absolutely ways to make it work. It just depends on, is that effort worth it for the features that you want? And is your team going to be able to support that kind of deployment?
Hey, so you were talking a lot about how this is also viable for smaller tech companies while still having the capabilities of a larger tech company, which I really appreciate. And so I want to ask you, in your experience, when a smaller tech company wants to build out all this stuff, is it better to use like AWS and Azure and one of those, larger service things, or you think it would be better to approach it from a different, smaller angle?
Ooh, that's a good question. So I'm a little bit biased because I work for Azure, but in general, what I'll say is you have to know your organization. Know what your priorities are. I'm sure it's not a surprise to many people that the economy is doing its thing right now and that our industry is not immune. Right now, it's probably going to be a pretty hard sell to your management to say, hey, let us spend a year and a bunch of money on this migration to add this tool. We won't see any benefit for about 2 years, but let me tell you, it's going to be really awesome to work on. That's a hard pitch. And cloud providers can help in that migration in automating things and giving you support. But I think the Agile Manifesto and iterative development play a big role here as well. Maybe you add a service mesh for a new project first, and you learn there, and you fail there. You use that as opportunities to create internal knowledge transfer across the teams who can be responsible for that. And then after things, the economy gets less crazy, you'll have some expertise that you can now put into practice in other places in your organization. hopefully you have a success story in case studies to show to your backend engineers, and they say, hey, you can do Canary? I want Canary, please give me that. And now you've got buy-in, you've got consensus, and that is one of your biggest tools you can use to sell to management for this kind of thing. So yeah, it's a bit of a in-between, it depends answer, but that's kind of been my experience of starting small and then using that to get it on management's radar. I think that's all right. Thank y'all.
Good job, man. Yeah, you bet, man. All right, thanks everybody. Okay, we are wrapping up for the day. Thanks so much for coming out. Got a few things. So first off, I really want to give a big shout out to DigitalMotion for all the work that they've done today. They were doing AV today. They've been doing an awesome job. They're also, yeah, thank you. Thank you so much, guys, really. They're going to be putting all these videos on YouTube, I think, in the next couple of days too. So, so that's also, you can be, if any of these talks you want to go back and look at, they should be available very soon. Thanks again, DigitalMotion. Thanks to all of our sponsors. This wouldn't be possible without them. One of the cool things about DevOps Days is that the surplus goes to scholarship funds too. So thanks again. We are probably going to do this again next year. So if you'd like to be involved with the core as a core organizer, we could definitely use the help. There's QR codes that you can use to figure out to get more information on that. If you don't get the QR code for some reason, feel free to reach out to me directly at the after party, which is going to happen at Goodfellas Pizza. I'm happy to announce that we're going to give everybody their first drink, their first beer on us. So come on down. Yeah. Okay. And then also we're gonna get you the appetizers too. So we're gonna have some appetizers available there too. So Goodfellas Pizza, you can Google it. It's kind of near the Moxie and stuff. It's about a half mile from here. But thanks so much for joining us again for DevOps Days. It was great to be here in person after a 2-year hiatus. And yeah, let's go have fun. Let's go over to Goodfellas and have fun. So yeah.